Okay, so today we're going to talk about the transformations of absolute value functions. So first things first, let's talk about the parent function of an absolute value function. So here I have my a value set to 1 and h and k are 0, which means we just have the absolute value of x up here, and this is our parent function. Just like all of our other functions, we can mess around with it and change it and move it all around the coordinate system, just like what we did with our other functions. Oops. And here we go. And then up and down. So our parameters actually work really similarly to our other parameters that we've done. And actually, they're exactly the same for the most part. So with our a value, oops, there we go. With our a value, if it is bigger than 1, you notice our graph gets skinnier. So we call this a vertical stretch. When we put it in between 0 and 1, so like a fraction or like 0.4, 0.6, it does get wider than the original or than our parent function. So that we call that a vertical shrink or a compression. If I make it negative, it reflects it across the x-axis, just like all of our other functions that we've talked about with our transformations. Now, if I make that go back to my parent function, okay, here we go. So now we're back to the parent function. If I move my h slider to the right, my graph goes to the right. So my h value is positive. It does go to the right. Now, please remember what that looks like in terms of our function, though. When our h value is positive, it is x minus 5.5 in the equation, if you're just to substitute that 5.5 straight in. So when we see an x minus, our graph goes to the right. If I were to make this negative, our graph goes to the left. And again, remember, if we have an x minus a negative, that changes it to an x plus. So when we see x plus, our graph goes to the left. Okay, and if I move it to the right, plus k means we go up, minus k means we go down, just like we're used to. Now, if I change my k value to, like, say 1, and I change my h value to 2, if we look here at my vertex of the absolute value function, it's 2, 1. So, and remember, this looks like an equation, x minus 2 and plus 1. So this h and k also happens to be that vertex of our absolute value function. And that makes sense because when you think about it, we're just moving that vertex around when we're doing our transformations. Alrighty. So moving it on over to here. Okay, so first things first. So y equals the absolute value of x is our parent function for our absolute value. And that looks like, oops, I'm going to draw, that's so sad. I'm going to draw myself a graph here. So absolute value just means the distance from 0. So if I wanted to graph this and say, hey, -2 is 2 units away from 0. -1 is 1 unit away from 0. 0 is 0 units away from 0. 1 is 1 unit away from 0. And 2 is 2 units away from 0. So if you notice, all of our y values are positive. Absolute values or distances are always positive. So when I plot these points, I get 1, 1, 2, 2, -1, 1, -2, 2. It ends up looking like that V shape. Now, this is not to be confused with a quadratic that looks like a U. That's a polynomial function. Polynomial functions are curvy. Absolute value function is not a polynomial function, so we connect them with straight lines. It is a V. And our transformations, so our a value here, if it's a negative a, this just means that it's a reflection. Across the x-axis. If we have an a value that is bigger than 1, we call it that's a vertical stretch. If a is in between 0 and 1, so like, oops, that should be an a. if A is in between 0 and 1, so numbers like 1/2, 2/3, anything that has a fraction or a decimal, we call that a vertical compression or a shrink. So it's a vertical compression. Oops. And one of these should be with the H. So we're going to scooch this one. We're going to say, hey, this one goes with the H. Actually, I'm just going to write it underneath the H and just kind of X that out. Alrighty, so my H, I have an X minus H. That means we are going to the right H units. X plus H, we go to the left H units. My K plus K means we go up. Minus K means we go down. Alrighty, and there will be a printed copy of notes that has all this information for you attached to either to this video or on tomorrow's assignment attached as well. So let's look at some examples and see how this goes. So the number of parameters that you have in your equation is going to be equal to the number of transformations you have. So for example, so we don't have an A value, it's just 1. We have nothing inside that absolute value, so there's no H value. So we just have this minus 3, which is a K value on the outside. So since it's minus and it's a K value, we know that we are going down 3 units. 1 parameter, 1 transformation, that's it. Now number 2, we have 2 parameters. So we have this A value, which means it's going to be a vertical shrink or compression. Since that 1/2 is in between 0 and 1. And my plus 4, x plus 4 is inside those grouping symbols or the absolute value symbols, which means it's an H value. Since that's an H value and it's x plus, if we look back to our other frame, x plus meant we were going to the left. So we can say that we are going to the left 4 units. And then last but not least, again, we have 2 parameters, so we have 2 transformations. Oh, except we actually have 3 because of this negative in front. So this negative means that it's a reflection across the x-axis. The 3 means that it's going to be a vertical stretch since that 3 is bigger than 1. And that x minus 5, it's inside those grouping symbols, so it's inside that absolute value symbol, which means it's an H value. So x minus, if we look back at the previous slide, meant that we were going to the right. So we are going right 5 units. All right, oops. So that is it for today, for today's lesson. If you have any questions, though, message me.